Hello and welcome to my YouTube channel. Here we are with the first of our question answer session. Luckily we have got two questions and in this session I'll be answering them. So let's begin. So the first question that we have got is from Mr. Zahid Khan, and he asks, what is the correct formula for calculation of the NMR timescale for a machine to record a proton NMR experiment? So first you need to understand what an NMR experiment means. An NMR experiment is the combination of the pulse width, the acquisition time, and the time delay between the two scans. That makes one NMR experiment. Now, the time required for this one NMR experiment can be different for proton, carbon-13, and other nuclei because of the fact that these nuclei have different gyromagnetic ratios. The relaxation times are different. So what we do is that we have pulse width, like that means you can give a 90-degree pulse, 45-degree pulse to start with, and then you have to acquire the data for a particular amount of time. Data acquisition or acquisition time, that is the time for which you obtain the FID, the free induction decay, the time domain signal, which is later on converted into frequency domain signal through Fourier transform. And after that, once you have acquired the data, you can still wait for some time, which is known as the time delay, so as to allow all the nuclei to relax back to their equilibrium position, that is the z-axis. So the combination of the pulse width, the acquisition time, and the time delay makes one NMR experiment, that is one scan. Now it takes very short to complete this one scan, so you can scan the molecule multiple times in very short amount of time on the new Fourier transform NMR spectrophotometer. That is the advantage of the new instruments, the new NMR instruments. And what happens when you scan the molecule multiple times is that you are actually increasing the signal to noise ratio, and you are increasing or enhancing the signal quality. Now you have asked specifically about the proton NMR experiment. So the normal pulse width for a proton NMR experiment, for a 1D proton NMR experiment, is 45 degrees because it will take less time. The pulse width usually is in microseconds. The acquisition time after that, that is in seconds, or you can calculate it and measure it in minutes. And then we have the delay time. Now that delay is for allowing all the nuclei to relax back to their equilibrium position. So the total time is the sum of the pulse width, the acquisition time, and the delay. And then you can, of course, increase the number of scans depending upon the quality of the spectrum that you have obtained. Another major factor could be the amount of sample that you have. So if you have less amount of sample, you might be needing to scan the molecule a lot more times than in an experiment where you are using a higher quantity of your sample. So for a normal 1D proton NMR experiment, it takes about 90 seconds for 16 scans. If you double the number of scans, the time is doubled. So for 32 scans, somewhere around 3 minutes are required to complete 32 scans. If you want to have 64 scans, it will take around 6 minutes, and so on. So from that you can calculate the amount of time required for 1D proton NMR experiment. I hope your question is answered. If you still are in doubt, you can still send another question related to this topic or another one. But thank you so much for sending this question. Now, let's move on to the second question that has been asked by Mr. Anwar Ali. And he has asked about the relative atomic mass, the definition of the relative atomic mass. And he says that in some literature, it is defined as the mass of an atom relative to carbon-12, while in other books or literature, it is defined as the mass of an atom relative to 1/12 of the carbon-12. Now, first you you need to understand what the term relative means. Relative means you have to relate it to something. Now, what is that something? That is the standard atomic mass unit, which is 1/12 of the mass of carbon-12, which usually is also known as 1 Dalton. So, relative atomic mass is the ratio of the average of all the atoms of all the isotopes of an element in a sample to 1/12 of the mass of carbon-12. Now, you also need to understand that element obtained from different regions might have different relative atomic masses, because elements obtained from different regions might have a different distribution or different abundance of different isotopes. Some of the isotopes might be radioactive, others might not be radioactive. So the different levels of radioactivities that might affect the overall percentage of different isotopes, and so the average obtained after that would be different for the same element obtained from a different region. So to avoid this confusion, you can go for a standard atomic mass, the standard relative atomic mass. But as far as your question is concerned, the relative atomic mass is this ratio of the average of all the atoms of an element in a sample to 1/12 of the carbon-12. I hope the question is answered, and thank you so much for sending your question. For the rest of the viewers, please share this video with your friends, colleagues, family, students, and ask them to send their questions on the email address given. Do not forget to subscribe and share this video. See you soon with answers to new questions. Thank you so much for watching.